So my family less than Smith's. Obviously, we're not comparing the two, but now using that less than symbol, it looks like we're linking Smith's with my family. So with this kind of syntax, you can see just how powerful it is to implement magic methods to use operators in different, interesting ways. Welcome back to Understanding Python. My name is Jake, and today I'll be covering class magic methods. Magic methods allow us to override functionality and create powerful interfaces for our objects. Understanding magic methods is a big step forward to becoming an expert Python programmer. So let's get started. Now, as a prerequisite to this video are my videos on classes and class inheritance, as I'll be assuming that baseline knowledge. If you haven't watched those, there will be links in the top right. Go ahead and give them a view, and then come back to this. Now in my previous videos, I've already introduced you to a couple of magic methods. These are the Dunder init and Dunder repr methods. So what do I mean by magic methods? Well, these are methods that you don't explicitly call. For example, when you're creating an instance of the class person, you're not actually calling person.dunderInit. Dunder init is automatically called when you create an instance of the person class. For example, let's create an instance of the class person, name it Jake, and we'll pass in a couple of arguments saying name, of course, is equal to Jake, and age is equal to 33. Now when you look at this, you can see that I'm not actively calling the Dunder init method, but Python knows that when you instantiate a class, it needs to call Dunder init. In actuality, it's actually calling another magic method, Dunder new, before it ever calls init. And it is Dunder new that passes along the self object to Dunder init. Now, I don't personally recommend writing your own implementations of Dunder new, as the use cases for that are fairly minimal, and that's more of an advanced Python subject. However, if that's something you'd like to see in the future, let me know down in the comments and I will add it to my list. So when we're instantiating person, Python is calling Dunder new, which then calls Dunder init. And of course, as we see here in Dunder init, it accepted some arguments and then sets values for the class instance itself, specifically name, age, family, and cousins. For the family class, it's also setting name and members. Another magic method that I covered in the previous video was the Dunder repr method. And if you remember back from that video, Dunder repr is what's considered the string representation of a class. Now the best practices for Dunder repr is to return a string that you would be able to recreate the class from later on. So if you look in what I'm returning, I've got self.name as well as self.age, which means that once I know how to parse the string, I could later on pass name and age back into a person class instantiation and get the same thing back. However, you do not have to do this. You could literally return any kind of string that you want. The choice is up to you. And you can see a deviation of that pattern in what I did for families repr down here. What I'm doing down here is returning all of the members of the family instead of the family name itself. So if I were to try to recreate a family class based on the repr of another family, it wouldn't be successful. However, this is the behavior I want from the family class. Speaking of which, let's create a couple more people and a family, and we'll see what this looks like. Okay, we've added a few more people, Amanda and Kiara. While Kiara is my dog, she's person enough for me. And then my family, the name of our family is Callahan, as that's our last name. And then we have a few print statements at the bottom to see what the repr prints out. So if you save and run this, we see we have Jake-33, Amanda-29, Kiara-13, and then an empty space. Now it's an empty space because self.members is empty. We'll get to populating that a little bit later. However, first, I want to cover another magic method that has a lot of confusion around it. And you can consider this magic method to be the opposite of Dunder init, and that is Dunder del. Now Dunder del is something interesting. This is the magic method that gets ran when an object is garbage collected. And garbage collection is a bit more of a complicated subject in Python, potentially worthy of its own video. However, I'll give a quick summary in this one. As you may know, Python has its own built-in garbage collection system, and the way this system works is by counting references. Well, an object's reference count is incremented or increased anytime that something else is actively referring to that object. For example, down at the bottom here, we see we have Jake, Amanda, and Kiara all pointing to person objects. So right there, we've increased the increment count of that object by 1. Once Jake, Amanda, and Kiara go out of scope, then that reference counter is reduced by 1. Since these variables are global to this file, that will happen when the file stops running. So to demonstrate that, we're going to add a print statement in here and say self.name waves goodbye. It's a little bit sad, but it'll get the point across. So let's save it and run it. And here we see we had our normal prints at the top, and then at the bottom as the file was closing, Jake waves goodbye, Amanda waves goodbye, and Kiara waves goodbye. These were ran right before the script itself finished executing, as there's no more references to those objects. So a couple more notes on Dunder del. Now it is called before the garbage collection happens. So it is technically possible for you to intercept the garbage collection of an object and save a reference to it in some other location. That will keep the object alive for the time being. However, this behavior is pretty finicky, so I wouldn't rely on it at this stage. There's better places to use it, especially if you're using a context manager, which is a subject I'll be covering in the near future. Another note is that running del on an object doesn't actually call the Dunder del method. And to demonstrate, what I'll do is first create another reference to Jake. So this is going to increment our reference counter. So when we call del Jake, it's not left at 0 and get garbage collected. So let's save it and run it. And here we see our normal behavior, Jake, Amanda, Kiara, demonstrating that calling del on an object does not actually call the Dunder del magic method. That only happens when it's garbage collected, as you can see down here, because the variable another Jake went out of scope, reducing the reference counter to the Jake object to 0. Now getting rid of those statements, we'll move on to our next subject. So right now, there's no good way to add members to our family. And of course, since this is a video on magic methods, we are going to implement another magic method in order to do this. And you may not be surprised to learn that the method that we're going to use is Dunder add. And this is going to take 2 arguments, self and object, because we'll be attempting to add another object using this method. Now, one thing to keep in mind when you're implementing a Dunder add method is that you want to control the types of objects that you're able to add in this way. So currently, I only want to be able to add people using this add method. And the way that I'm going to check this is run if is instance object person. Meaning if object is an instance of person, then we're going to do something. And the first thing that we're going to do is we're going to set an attribute on ourself. And that attribute is going to be the object's name or the person's name. And that's going to reference the object itself. This allows us to do things like myfamily.jake, and that'll reference the Jake object. Another thing we're going to set is on the object.family, we're going to have that reference this family instance. So a person added to a family will have a record of what family they belong to. And then finally, we're going to add them to the members. And now we've just written our first add magic method. And the way that we would use this is simply saying my family plus Jake. Isn't that nice? This is why it's considered a magic method, because we're not calling my family.add and using Jake as an argument. We're simply just saying my family plus Jake. We can add in everyone else the same way. My family plus Amanda, and my family plus Kiara. Now down below in our print statements, instead of just printing out Jake, Amanda, and Kiara, we can prove that they're a member of my family by accessing them with the dot notation. So my family dot Jake, Amanda, and Kiara. We can also print with an F string Jake's family, and then say Jake.family.name. Remember that when we added Jake to the family, we set a reference to ourself as .family in the Jake object, and we have a .name attribute. So that is accessed with Jake.family.name. Now some of you may have seen an issue with the print statements as they currently stand. However, let's let it run and explain why it's going to fail. Here we go. We have an attribute error. Family object has no attribute, Jake. And that's because on line 31, we use setAttr to self with object.name. And Jake's name starts with a capital J. So now we have to change these dot attributes in my family to their capital counterparts. If you wanted to use the lowercase notation, you could always use .lower on name here, and since it's a string, it'll lowercase the entire name. However, let's keep it as is. Okay, I've saved, and let's run it. Let's give ourselves a little bit more room, and here we see something interesting. Now that they've been added to my family, we can see that they have a last name. So Jake Callahan 33, Amanda Callahan 29, Kiara Callahan 13. Jake's family is Callahan. And then finally, my family printed out, also showing the members of the family, Jake, Amanda, and Kiara Callahan. And of course at the bottom, we all wave goodbye as we go out of scope. So now that these first three lines are redundant, because printing my family prints the equivalent of these, we can get rid of them. And we can also get rid of the print statement for Jake's family, as that attribute's also printed out in the final output. So we'll get rid of that as well. Save it and run it and see how clean that is. Jake Callahan 33, etc. Now you may have remembered back towards the beginning of the video when you saw that we also had an attribute in person called cousins. Well, we currently don't have a way to link cousins together. And what's the real world relationship between people and their cousins? It's effectively two families linked together. So the way we're going to implement this is, you guessed it, with another magic method. Now the magic method that I'm going to use doesn't make sense by itself. It's more of what's called syntactic sugar. It looks good. And then what I'm going to use is Dunder LT. Again, self and object. And Dunder LT is what's called when you try to determine if one object is less than another object. Obviously, it doesn't make sense to check to see if one family is less than another family, so we can use the character. To represent a different kind of addition or assignment. I'll go ahead and write out the code and walk you through it in a little bit. And the basic logic behind this is that we want to make sure that we're only checking to see if it's another family. And if so, we're going to go through both our members and their members and then assign each as cousins. This way, a person in one family is cousins with a person in another family and vice versa. So to show this off, we'll make another quick family. We'll just call this family Smiths, as that is generic enough. And this of course is going to be a family whose name is equal to Smith. And for the Smiths, we're going to add in a person whose name is James, who is, we'll say, 30 years old. And then we're going to add in another person whose name is Rick, and we'll say that he's 31. And let's not forget to say age for the both of those, as we don't want to put positional arguments after keyword arguments. Okay, so now the Smith family is populated. And the way that we're going to link these two together is using the less than operator. So my family less than Smiths. Obviously, we're not comparing the two, but now using that less than symbol, it looks like we're linking Smiths with my family. So with this kind of syntax, you can see just how powerful it is to implement magic methods to use operators in different interesting ways. And now that we've created a relationship, let's print those out. Okay, we've got a few more print statements, broke it down in a little bit of sections. So we have my family, then printing out my family. The Smiths, print out the Smiths. Then we're going to print out Jake's cousins and James' cousins. Let's see how this runs. All right, so we see under my family, we have Jake, Amanda, and Kiara Callahan. Then we have the Smith, which is James Smith and Rick Smith, followed by Jake's cousins, which is a list of James Smith, 30, Rick Smith, 31, and then James's cousins, which are everyone that's in my family. And of course, they all wave goodbye at the end. Beautiful. But let's do one more example. Down here, under less than, we're going to introduce another magic method, the last one for this video, and that will be Dunder contains. Again, you're going to check it for self and object, and this is going to be really simple. Return object in self.members. So this is a way to have a bit more control over membership checking. Now you've seen this before in things like lists, strings, dictionary keys, where you check to see if, in the example of a string, if a certain substring or a certain character is within the string. You can also control that for your class itself. So for family, what we're going to check to see is if a certain person is in the family, and the place that we store that information is in self.members. So we're redirecting the contains call on our family instance to a contains call on self.members. And to check this is really simple. Down here, we're going to print a check saying Jake in Callahan's, and the check for that is going to be Jake in my family. And then we can do a negative check for Jake in Smiths. So Jake in Smiths. Save it and run it. And here we see on these two lines, Jake in Callahan's true, Jake in Smiths false. So this is a nice way to have more control over contain checks using the contains magic method. And that's really the intention for all of these magic methods, is to be able to have greater control over the behavior of each in your particular class. Now there's a whole bunch more magic methods in Python. Many more that I could possibly cover in this video, some of which I'll be covering in future videos. However, I'll be linking to the current documentation on all the magic methods within Python down in the descriptions. But for now, that wraps up this video. Now that you understand magic methods, try using some in your classes and see what interesting behaviors you can come up with. If you have anything you're particularly proud of, let me know down in the comments. What's your favorite trick with magic methods? Or is it something I showed today? As always, today's code will be added to the Understanding GitHub repo, so check the description for a link. And of course, if you have any questions or suggestions for topics you'd like me to cover, leave a comment for me. To keep up with this series, please consider subscribing. Thanks for watching.